Hello and welcome to today's video. So on the workbench today we have all the bus bar interconnects and BMS wiring done for the second battery pack for my truck. And you can see I've got all of the cell taps here. You can double check me, but this is the negative most terminal, and we cruise around over here to the positive most terminal. And we should have one of these tinned cell tap pickups on every cell, and then we come out all the cell tap wires come through this cable over here into the BMS, and same with the other side. So we pick up all the cell taps, goes through this cable into the other BMS connector. It is split in two, so this obviously just picks up everything from this point to the right is on this connector, and everything from this point left is on this connector. That's by design. So that works out pretty good. Yeah, essentially all of these wires I will eventually dress them up so they're nice. It'll look like this when it's done. This is the original one out of the Nissan Leaf. You can see the two connectors on here are the same ones that are right here on either side. So I kept the pinout identical. I did have the wrong connectors because originally it had these on there, so I removed all the pins from these guys and then plugged them into the two correct connectors so they can plug in. They are technically backwards compatible. Like if I needed to, I could unplug this battery pack and plug it into this side if the need arises, if I need to swap something, or maybe the layout works better to have it the other direction. You can do that. So they're definitely swappable. Yeah, so that turned out pretty good. That wasn't too difficult. It's a lot of wiring, but yeah. How it's wired is this is from the Nissan Leaf 2013 owner's manual, or yeah, I guess it's the service manual. But essentially we've got 20 cells here on that 24-pin connector, 20 cells on the 32-pin connector, and then essentially this has been replicated up here. Before, this just went straight from all the cell taps right to the BMS, because this side of the BMS is connected right up to the front battery pack where it comes out, and then these two go off to the two rear battery packs in the actual Nissan Leaf, the actual vehicle. So essentially what I've done is I've just created these two packs and then created another instance of them up here. So it's identical. I didn't draw it in. You can see the numbers here are the actual BMS chips. So we're only going to use 1 through 5. We're going to jump over 6 and 7 because I'm not using all, like this group would be 48 cells. I'm not using all 48 cells. I'm only using 40 of them, 20 there, 20 there. So we're going to jump over these 8 cells. They're physically not present. There are no BMS wires, like there's no taps for those cells because they're not present, but I did keep the wires in this harness just in case. But yeah, they're not needed. You could actually plug in like the actual two halves, two back sections from a Nissan Leaf into this assembly, and it'll work. Like I kept the pinout exactly the same. So the same thing up here, we've got the 20 cells and 20 cells, and then we're going to use BMS chips 13 through 17. We're going to bypass 18 and 19, and then 20 through 24 will still be used. So yeah, that is essentially what we're going to do. Oh yeah. So to wire all this stuff up, I had to decode I don't know if you've ever looked at their drawing here. Cell 1's on pin 33, and then it's 50, and then 34 and 51. It's like these are just really weird pin numbers for the fact that they're multiple connectors, because this is actually 2 connectors, and then this is 2 connectors. But the pin numbers don't match the connectors, which is really weird. What they do is essentially they start with pin 1 here, right? And they just count across, and then get this one, and then that's why you start off with like 33. That's this pin, and then they count through all of these connectors to get to whatever the 100 and whatever the last pin is, 143. Yeah, it's like 143 is like the last pin. Yeah, so I went and redid it because, yeah, that's ridiculous. Let me turn this light off here. So essentially, I redid the BMS connectors. So this is the CAN connector, that's that gray one, and then the temperature probes, and then redid all of my. This is all of the 4 connectors that are on the BMS unit, and then I've got their pin numbers. So there's that 33, which is at the top, but then I actually pinned it to the correct pinout for the connector, which even this is in backwards because they start off at 16, count down to 1, and then, yeah. But having it in this layout, it makes so much, like the numbers make sense, because if you look at cell 1, then it's the tap between 1 and 2, then the tap between 2 and 3, and it just alternates back and forth the whole way, all the way till you get to the bottom, and it's cell 95, 96, center tap, and then cell number 96. So it does make sense when you actually look at it differently. Yeah, so that took a little bit to decode and get it right. And then this other one is my physical wiring. So from this to those are the 2 cables that I made. So this section goes over there, and then these 2 go over to here, and that's the pinout for this cable right here. And this is the existing one, but I drew it out anyway, you know, just to be complete. So this is this is the stock Nissan Leaf cable, and then this is the one I made. So that's my pinout. So yeah, when I was doing it, there's a bunch of unused pins on this connector. So I was like, well, let's take a look at that and see what do they go to. And there's a whole bunch of not populated stuff, and I can show that to you here in a second. So this is the BMS. Let me turn the light back on so you can. So if I take the cover off, this is the modified one where I replaced the microcontroller with my own micro. But if you notice, there's a bunch of unpopulated stuff on here all over. And I'm thinking I might actually use it. I might populate it. Here's my thinking. So originally when I did this, because I'm running 2 parallel packs, I want to have separate contactors, separate pre-chargers, separate current sensors. So if you got packs in parallel, so if one pack isn't produced, you know, you could tell that current's flowing from one pack into the other by looking at the current sensors and say, hey, something's wrong. We can open up the contactor, protect the, so we're not dumping energy into the other battery pack, you know, that kind of stuff. We want to, you know, have some level of safety. So that's what I was making these power controllers for. So they were going to take in power. So you've got the A and the B side here. We were going to take in from the battery pack and then out to essentially a main system bus. And there'd be another one. So there'd be 2. One from each thing. Actually, there'd be 4 of them because there'd be 2 in the front and then 2 in the back. Right now, we're just dealing with the back battery pack. We're not dealing with the front battery pack yet because that's going to require a little bit of mechanical engineering to make, to shrink it and double stack it so it'll fit in the front battery box. So we're not going to tackle that yet. We're going to do the back battery box, get that up and running with this system. It'll be much easier. Get back on the road that way, and then we can work on the front battery pack. Anyways, so yeah, there'd be 4 of these in the truck, but just 2 in the back. And so we would detect, you know, the main stack voltage, measure it, measure the voltage coming in, turn on the pre-charger. When they get close, then we click in the contactor, and everything's good. Do the same thing for the other one. We're good. Look at that. The main stack. We look at our voltage here. If they're close, we can pre-charge, click in the contactor, you know, basic stuff. So I had built these up. The code's done for them. They work. But I'm thinking about ditching them. So all this engineering, I might use part of it. This is my plan. So hear me out on this. So I'm looking at their design here on their, this is the Nissan Leaf BMS. Like I said, it's the one that I replaced the microcontroller on it. When I replaced this, I made my interposer board. I picked up all of the I/O that touched the micro. This is a DSPIC 33 EV series, which has a peripheral pin select. So I can assign any function to any pin, pretty much any function to any pin. So it can be a UART, I2C, SPI, inputs, outputs, A to D, DAC, you know, whatever. Tons of stuff. Very flexible. I really like the micros that have peripheral pin selects because it makes the layout really easy. Because if you see the layout of this, it's just grabbing the nearest pin, mapping the nearest pin to the nearest pin on the micro. But anyways, so if we're looking at this, what do we see here? Spots for two fairly big N-channel MOSFETs. It's even got spot for the flyback diode. So I think at one point they originally designed this BMS to control the contactors. And if that's the case, I don't need this board, because that's what this guy's function was to control the contactors. Because the Nissan Leaf, the contactors are controlled externally. They're not controlled by the BMS, like the vehicle control unit, or yeah, the vehicle control, VCU? Yeah, vehicle control unit controls the contactors. This is one of the contactors out of a Nissan Leaf. But it's not controlled by the BMS, at least not directly. Somebody else supplies power to turn them on and off. Same with the precharge, the prechargers, or the precharge relay. So what's interesting is we have these two N-channel MOSFETs. Looks like a SOT, what is that, 223 package. We've got the catch diodes, and they actually do go over to the unused pins on this connector. But we'll need something to also turn on the prechargers. Well, also in here, not populated, is a source driver, and then these two are also source drivers. One of them supplies 12 volts out to the interlock, the safety interlock. I got a picture of it right here. It supplies power, so there's the detect out, so it puts 12 volts out, goes through all this, and then reads it back on one of the other pins to see if any of your high voltage connectors are unplugged. Well, I don't really need that, so I can use that 12 volt out, that source, for precharge, and then I can populate the other one, and you also use it for the precharge. So I can get my two contactors and two prechargers. Now, the other problem that I've got is I don't have a way to detect what the voltage is on the main system bus. Technically, there are two ways to do it. I have an LG5 battery charger connected over CAN bus, and I can power that with 12 volts externally, and it's not plugged into the wall, and I can bring it online, and I can use that to read the system stack voltage. So I could I could use that to read and go, okay, turn on the precharger, wait for the voltage to charge up the main system bus, click in the contactor, then turn on the next battery pack, turn on its precharge, measure the voltage between. Now we know the bus voltage and we know battery, precharge that into that one if there's a difference, and then connect it into the main system bus too. So that would work. The other thing I could do is if we had extra A to D channels, where would we get extra A to D channels? Well, it turns out on the back side, not populated, are 3 more A to D channels. So they've got 2 A to D channels. These are just the diodes for the high protection diodes, because it's 0 to 5 volt in, and so they got a couple protection diodes. But you can see these run back over to the micro. But they're essentially 0 to 5 volts in with some protection, some low pass filters and everything. And you can see there's two populated. One of them is the 0 to 5 input from the current sensor. The other one is 12 volts. It reads the 12 volts coming in. So there's a voltage divider on this one. And it reads the 12 volts, incoming 12 volts. So my guess is that if the voltage was getting too low, it could write something to the EEPROM or do something while it's shutting down. But yeah, there's another one here, and then another two up here. So there's 3 more A to D channels that are available, which is nice. So I think we might be able to reuse the isolated high voltage sense on this guy to be able to read the system pack voltage and then bring those into the BMS. So it would require one external board. It's not the end of the world. I mean, we've already got it designed for this, so we can just copy that. Not that big a deal. So I'm also looking at this, and one other thing we would need is another current sensor, because we only have the one current sensor. This only supports one current sensor, which was another reason why this has a current sensor that plugs into it. It goes in the cable, and then it plugs in one of the connectors. So we need a second current sensor. But I've got that extra A to D channel. So if I've got 3 extras, so I could pick up the other current sensor and then the voltage, stack voltage for either the A and the B side after the precharger. Even though they'd be connected together, I guess technically you get away with one, but maybe you want to double check. I don't know. We already know the pack voltages because we can measure it here and here. So we know what the battery packs are doing. We can measure those voltages by adding up the cells, which is what they do. There's actually over here, is it on this side or the other side? That's on this side. There's a whole nother chip. It's another one of the spots for one of these chips that actually did measure the whole pack voltage across. Another one of the isolated ones, it measured the entire pack voltage, but they removed it because I guess somebody said we can save money by just adding up all the cells and do it in the micro. So that's what they do. Cost cutting. Oh, and speaking of cost cutting, there's also, if you look in here, these are input structures. So we've got, these are 12 volt inputs. So there's a voltage divider, a low pass filter, and then the actual MOSFET itself. And you can see there's another one that's not populated here. There's also one up here that's not populated. You can see it, the MOSFET going back. That's not populated. And my guess is it looks like this guy is tied to the output of this, so you can read back. This is like multi-configurable. You can make these to be sync bits, or they can be inputs, or you can hook them both up, and then you can get confirmation that your sync bit turned on, that you're actually, you could read that back. What else? There was some other. So I'm pretty sure that's what those are. I thought there was one other thing. There's some other. Down here's another. These two. I don't remember what those ones were. I'd have to go back and re-engineer it. But I think, given the fact that the output, no, that might be. Yeah, you've got one drive in the other one, so I'm not 100% sure on that one. That one might be another source bit. This guy supplies 5 volts to the current sensor, because the current sensor is 0 to 5, and it runs off 5 volts, not 12. This is a 5 volt regulator that can be turned on and off by the micro, and it only puts out 150 milliamps. If that isn't enough to run 2 current sensors, there's a spot right here for a whole nother one. It's even got, so you can see the diode goes there, capacitor, yeah, capacitor would go there, and then it's got a spot for the capacitor, just like this one. And yeah, so and that's got these are adjustable regulators, and you can see the resistors down here. Set it. You can set the resistors there and get any voltage you want out of it over here. So if that can't provide enough to power 2 current sensors, we can get the other one. The reason they're switched is so they can, when it goes into sleep mode, it shuts off power to the current sensor, so it doesn't waste the 100 milliamps or however many milliamps it takes to run the current sensor. But yeah, the more I look at it, it wouldn't be hard to get all these parts and just populate it. And then since I've got my micro running it, I can toggle those bits and do whatever and have full control over everything. So I don't know, what do you guys think? I think I can do everything with the BMS. And then it's all local, so it's the one making all the decisions. I already got a micro. That was the other thing. Then I've got 4 more microcontrollers out in the vehicle that I have to maintain code for and make them firmware upgradable and all that. Something changes. Instead, I can just put it all in here or in there. I don't know. I kind of like this idea. I've got the connectors. I've obviously can repin them pretty easy, and they just pop out once you know the trick to it. And yeah, I think that's what I'm going to end up doing. Is despite engineering time that was spent on these guys, I think they're going to get scrapped. We'll keep the contactor, maybe the pre-charge resistor. I don't know. Maybe I don't know. We'll see. But that's only if we need that high voltage sense. Otherwise, I can just use the Nissan's own contactor assembly with the pre-charge resistors in it and everything. Or maybe I'll make my own. I don't know. Just mount them somewhere. But yeah. Anyways, a really long video. Yeah. Anyways. Oh, I think I know what the other. That one's the other sync bit, source bit was for. I drew it all up here. Hold on. I don't remember if I showed you guys this. But yeah, this is kind of like my preliminary. So we got pre-charge A, pre-charge B. We've got our ignition signal, our interlock input, which I may or may not actually use. I've got a charging, so when you plug in the battery charger, it can wake it up. I've got charger enable. I'm not 100% sure that goes out. That's kind of like if I wanted to supply the 12 volts to the charger to wake it up so that I could use its internal high voltage isolated voltage sense to read back the stack voltage, and then use it to as part of the pre-charge, and then once it's done I shut it off, kind of thing. Then I got my amps current sensor for the A side, and I got current sensor for the B side over here. And then this is if I did the 0 to isolation. Essentially, it's like 0 to 200 volts becomes 0 to 5 volts isolated for A and B stack. And then I've got my heater control. There's an input on the heater, like it can tell if the heater's on or off, so I might keep that. And then, of course, the 2 big sync drives for the 2 contactors. And then, and then my temperature sensors. So, yeah, anyways, thanks for watching. Bye.